Today in the workshop, we've got our heads in the Arduino IoT Cloud. You'll see all the new IoT Cloud features for 2024, including a new interface and support for many more devices. We'll also build a cloud project that uses triggers to send notifications. There are clouds in the forecast today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we're going back into the cloud, the Arduino IoT Cloud. Now, we've used the Arduino IoT Cloud several times here in the DroneBot workshop, but it's been a little while, and there have been many changes to the IoT Cloud, so many that it doesn't even look the same as it did before. It's got a brand new interface, there's an updated editor, there are a number of new features in the cloud, including something called triggers that will allow you to send a push notification or an email in response to specific events, and there are many more devices you can connect to the Arduino IoT Cloud. In fact, you can connect just about anything that can connect to the internet to the Arduino IoT Cloud. There are so many new features in the cloud, in fact, that I can't jam them into one video. So this is the first in a series of videos that I'll be doing on the Arduino IoT Cloud and the updated features for 2024. So if you've used the cloud before, this video will be an excellent update to get you back to speed with all of the new features. And if you've never used the Arduino IoT Cloud, then this video will serve as your introduction. So let's go and get our heads into the Arduino IoT Cloud. The Arduino IoT Cloud is an Internet of Things platform that works with Arduino devices, non-Arduino devices, APIs, and pretty well anything that you can connect to the Internet. The IoT Cloud is an ideal platform for makers and experimenters, as it allows you to build Internet of Things projects without having to worry about all of the tedious back-end and security stuff. In order to work with the Arduino IoT Cloud, you need to understand a few simple concepts, and we'll go over those now. The first concept is devices. Devices are essentially virtual twins of the hardware that you've attached to the IoT Cloud. The platform supports both Arduino and non-Arduino boards. You can also use LoRaWAN, Ethernet, and cellular boards available from Arduino. In addition to working with C++, you can also work with Python, MicroPython, or JavaScript devices. In order to attach devices to the Arduino IoT Cloud, you'll need to install the Arduino Create Agent. It's a very simple program, and it's available for Linux, Mac, and Windows. All new devices attached to the cloud will be assigned some secret keys, and you'll need to save that. Arduino provides a very simple method for doing this. The next fundamental concept of the Arduino IoT Cloud are things. Things represent connected devices and the data variables associated with them. A thing is actually a container that contains devices, the network credentials to attach those devices to the network, and cloud variables. When creating a thing, you're going to require that device secret key that was assigned to your device when you connected it to the IoT Cloud, so make sure you have a copy of that. Cloud variables are one of the key concepts of working with the Arduino IoT Cloud. These are variables that exist within the IoT Cloud. You'll define your cloud variables when you define your things, and cloud variables are used with all of your devices. Any change made to a cloud variable on a device is passed to the cloud. Most standard variable types are supported by cloud variables, and in addition there are some specialized types that are unique to cloud variables. Cloud variables can be read-write or read-only. You can update the value in your cloud variables periodically, or you can set them to update every time a value changes. Another key concept of the Arduino IoT Cloud is dashboards. Dashboards are your control panel for your cloud applications. There are desktop and mobile versions of the dashboard, and you can configure them independently. Dashboards are very easy to use. They employ drag and drop widgets, and these widgets connect to cloud variables. A trigger is a newer feature in the Arduino IoT Cloud. A trigger occurs when a cloud variable condition has been met. You'll use triggers to trigger an action, and this action can be sending out an email or a push notification to the Arduino IoT Cloud mobile app. Currently, triggers only support Boolean and string cloud variables. Another update to the Arduino IoT Cloud is the IoT Cloud Remote app. This is available for both Android and iOS. And there have been more changes made to the IoT Cloud Editor as Arduino continues to bring it closer in functionality to the desktop editor. And so that's the overview. Now let's go log in to the Arduino IoT Cloud. Now here's the main console screen for the Arduino IoT Cloud, and if you haven't been here for a while, this is going to look very different than it did before. They've pretty well consolidated everything onto one screen, and it's pretty nice. Now I'm going to assume that you already have an Arduino IoT Cloud account. If you don't, it's pretty easy to set one up. Now, this is the home page over here, and it just kind of summarizes some files you've been working on recently, and also has a couple of ways you can get started if you're brand new. It's got documentation, getting started wizard that you can go through. You can basically build a little cloud project right from here to get yourself familiar with everything. Now, down the side, you'll see all the main elements of the cloud. So over here are the sketches that I've got, and for every sketch, it also shows you what it is associated with over here. So here's the associated thing to that particular sketch and what device it's associated with as well. And we'll go into devices. We can see all the devices that I've added to the cloud. We're going to be adding some more of them a little bit later. Here are the things that I've made for my cloud. And here are my dashboards. And here's a trigger. And so all of the main elements for the cloud are right over here and very easy to get at. They've also got some resources down here, and these resources are things like their forum, their project hub, and a number of tutorials for getting started with the cloud. There are complete courses over here on using the Arduino and the Arduino IoT Cloud, and you can get going through those. And you can also look at some templates. If you're going to build a cloud project, you don't necessarily need to start from scratch. You can use one of these templates, and they have a number of different templates over here you can choose from. Finally, we've got integrations. These are products that I've integrated with the cloud. In my case, I've integrated Edge Impulse, so it appears over here. And the last bit here is just the personal usage for the cloud that I have done, my plan usage. And so this is the screen again, the main console screen for the Arduino IoT Cloud, and we are going to be using this to build our cloud project. All right, now that we've got all the fundamentals down, it's time to start working with the Arduino IoT Cloud. And so what we're going to do in today's video is we're going to build a cloud project. We're going to start off with an Arduino Uno R4 Wi-Fi board, although you could use another Arduino Cloud compatible board and it'll work just fine. And we're going to build up a project that eventually will also include a second microcontroller, an ESP32. So let's see how we hook up our Uno R4 Wi-Fi and start working with the Arduino IoT Cloud. We're going to build a project using the Arduino IoT Cloud, and we'll be using an Arduino Uno R4 Wi-Fi board as our device. We'll be connecting a servo motor and a push-button switch to the Uno, and then connecting it to the IoT Cloud. After that, we'll build a dashboard so we can interact with our device. We'll be using the Cloud Editor, and I'll also show you how you can do your editing using the IDE 2.0 that you're already familiar with. In addition to the Arduino Uno R4 Wi-Fi board, we're going to require a servo motor, and the standard SG90 servo would be an ideal choice. Now, some folks power the servo motors from the 5-volt supply on the Arduino board, but I don't like to do that. And besides, servos work better with 6 volts anyway, so we're going to give it a 6-volt power supply. This can simply be 4 AA cells if you wish. We'll also require a push-button switch. This is a momentary contact, normally open push button, pretty well a standard device that you probably already have. We'll begin by connecting a ground connection from our Arduino to the negative connection of the 6-volt DC servo power supply. We'll also connect that ground connection to the ground connection on the servo. On most servo motors, this will be a brown wire. We'll connect the positive side of our 6-volt power supply to the positive side of the servo. That'll be a red wire on most servo motors. And we'll connect the servo's control lead, which is usually an orange or a yellow wire, to GPIO pin 11 on the Arduino Uno R4 Wi-Fi board. Next, we'll connect one side of our push button to GPIO pin 5 on the Uno, and we'll complete the circuit by connecting the ground to the other side of the push button. And so now that our circuit is wired up, let's connect it to the Arduino IoT Cloud. So now that we've wired up our Uno R4, we'll need to add it to the Arduino IoT Cloud. And of course, this is a device, so I'm in the Device tab of my Cloud console, and right over here is a button that says Add Device. Pretty well seems straightforward. Let's click it. And we get the Setup Device wizard. Now we have three selections over here. We can add an Arduino board, which of course is what we are going to do, a third-party device, and this is mostly ESP32s and ESP8266s, as well as LoRaWAN products. And over here, a manual selection, and here we can add just about anything that can speak Python, MicroPython, or JavaScript. Of course, we have an Arduino board, so we're going to click over here. And I've connected my board to the USB port. You'll need to do this, of course. Now at this point, it's found my Arduino Uno R4, and we can continue. But I should mention that when you first do this, you're probably going to get a pop-up saying that you need to install the Arduino Create Agent. The Arduino Create Agent runs on your computer, and it's kind of the bridge between the USB port and the Arduino IoT Cloud website. So you need that or this won't work. If you're prompted, you'll get a download link for it. It's available for Linux, for Mac, and for Windows. And just download it and install it. You'll note that it runs in the background all the time, and you'll have a little Arduino symbol on your taskbar to let you know it's working. So as I said, I've got the agent, and it's found my Arduino Uno R4 board. So I'm going to go and configure that board. Now it says to give your device a name, and it will suggest a name for the device, but you probably want a different one. So we're just going to call this one Uno R4 Test. Uno R4 Test Board. Why not? Okay, and I'm actually going to copy this as well too, and I'll show you why. This is this little trick of my own. I'm going to copy that name, and I'm going to go Next. And now it's going to say that it's giving me a device ID and a secret key. Now this secret key is extremely important. If you don't have this key, you can't proceed with the further steps because this is part of the security setup. So you can copy that right now to your clipboard, or you can download a PDF, which is what I'm going to do. I'm going to download the PDF, and this is why I copied the name. What I'm going to do is I'm going to paste that over here. And so now I know what this is the secret key for, because it's always going to come up as Arduino device secret key PDF. By pasting the name in front of it, I know what device it is. So I'm going to save my secret key. And I've saved my key. I can confirm I saved my key, and I will continue. Now it's going to make the device IoT ready, and as you see here, it says this process can take up to 5 minutes, and with the Uno R4 it often does take 5 minutes. So I'm going to stop right now because I don't think you want to watch this for 5 minutes. It's just going to spin that number 3 wheel and eventually check it off, and our Uno R4 will be added as a device in our Arduino IoT Cloud. So now that our device is complete, the next thing we're going to do is build our thing. And so I'm in the Things tab of the console, and we can add a new thing. We'll click Add Thing, and we get a thing right now, and it starts off as an untitled thing. So let's give our thing a title first of all. And I'll just call mine Uno Test Board Thing. You can call it anything you want, of course. And you can see we've got 3 sections. We've got the cloud variables, the associated device, and the network. So let's associate our device first of all. And this is our Uno R4 test board. We'll associate that. And now we need to put in our network credentials. And this is where you're going to need your secret key. So we'll click over here, and we'll give it our Wi-Fi name. You need to give it your Wi-Fi password. And you need to put in your secret key. And I've got mine in my clipboard right now, so I'm going to paste it. And we'll hit Save. And the next thing we need to do is to add some cloud variables to our thing. And we're going to add two to our thing, one for each of the peripherals we have on the board. So the first one we're going to add is for the button. So I'm going to call the variable button state, and we're going to select the type for our variable. Now there's a number of different ones to choose from, but the basic ones are down here. And in the case of our button, I want it to be a Boolean, so we'll do that. Now you have the permissions. Is it read, write, or is it read only? Well, in this case, the push button is only going to be sending a value and not accepting one, so it's read only. And you have a choice as to whether to update it whenever the value changes or periodically, say once a second or so. You get to choose the period if you choose that, but I want it to update on change. So I'm going to add my variable. And you'll note over here in the sketch tab, I got a little 1. That means that the basic sketch that this is writing in the background has now been modified with one addition, and that being my button variable. I'm going to add another cloud variable now. I'm calling this one the servo position. And this is going to be an integer. So this is the number from 0 to 180 that we will be feeding to position our servo motor. Now we want this one to be read and write because we need to be able to write to this. And we're also going to keep it as on change. And so we'll add that variable. And you'll note that we've had two additions to our sketch. Now we'll go over to that sketch tab, and I'll need to let you know something. This is the basic editor, and it actually is going to be going away. Arduino is getting rid of this basic editor at the end of March 2024, so you'll eventually just go directly to the full editor. So we may as well just go directly there right now. And this is the full editor. And I'm just going to hide this right now because I don't want to do a tour. Now, the full editor is becoming more and more like the IDE on your desktop, but it's still not quite there. It's got a few features on the side over here. You can go to all your examples like you do in the regular IDE. Here's where you add libraries. And over here, there's a number of reference functions, so you can look at all the different functions that are in the Arduino implementation of C++. It's kind of nice. In any case, we're not going to look at that right now. What you will notice is that we have 4 files. Let's just make it a bit bigger here. This is our main sketch, and this is the one that we're going to be working with. The README is something it generates, and you can start adding your own information onto this, like how you're wiring your circuit up and everything. The properties of the thing are being generated automatically whenever we change properties in our thing panel, and the secret tab contains all of your information, such as your Wi-Fi credentials and that secret key. So we're just going to be focusing on this one, and this is what's already been generated for us. It says it's added these automatically, the integer of servo position and button state. Those are the 2 cloud variables. Otherwise, it sets up a basic sketch that we can modify. And at the bottom here, you'll notice it also added a function on servo position change. And this is basically for the servo position cloud variable. Because it's a read-write variable, this will be called every time that variable is changed. And so this is how we're going to interact with that variable. So now let's take a look at some code we can add to this to make our project actually work. Now, in order to make this a bit easier for you to see on the screen, I've gone into my settings in the Arduino IoT Cloud, and I've changed my font size up to 24, so you should be able to see that a bit better. Now, we are going to start adding code. In fact, I've added a few lines of code already, just for the servo motor. Remember, we've got a servo motor and a push-button switch attached to our board, and the servo is controlled with this servo position cloud variable, so keep that in mind. Now, the first thing that I did was I included the servo library, so that's just the standard way that you would do it in any Arduino sketch. And the same as you would with any other sketch, I've defined an object for the servo, and I've just called mine my servo. You could call it anything you want, of course. Then I go into setup, and in setup I need to attach the servo to the pin that it's attached to, and we're using GPIO pin 11, so I did my servo.attach to 11 over here. And then we go all the way to the bottom to that function that they provide provided for us, on servo position change, and I've added code to that. Now remember, every time the variable servo position changes in the cloud, this will be called, and what we want to do is we want to move the servo motor when it changes. So I'm going to move the servo motor, do a myServoWrite, and the value of servo position, the cloud variable that is going to contain the position of the servo. And so that's all I need to do. And so now I can just load that up to my Arduino Uno and then start creating a dashboard and see if this will work. So we just do this to do an upload. And by the way, the verify on the cloud takes quite a while. It's a lot longer than it is on the local Arduino IDE 2.0. Also, there is a little quirk I've noticed. Sometimes the very first time that you attach to a board, you might get a failure. If that's the case, unplug it, plug it back in, do it again, and it'll probably work forever and ever after that. I'm not sure what causes that, but just thought I'd throw that in. And anyway, we're going to verify and upload this to our board, and then we'll move on to make a dashboard for this so we can control our server. And so now I've navigated back to the dashboard screen, and I'm going to create a new dashboard. So we're going to hit the new dashboard, and we can give our dashboard a name other than untitled, and that should be fine. And now we can start adding widgets to our dashboard. And we're going to look for a widget to control the servo motor. I'm going to pick this value widget to start off with. Now the name of it is value, but we can call it something else. Let's just call it servo. And we need to link a variable to it. And so we're going to go down to our Uno testboard thing, and we see the two variables, and there only is one variable that we can use, an integer, because a Boolean can't be linked to it. So they got that grayed out. So we'll pick that integer, and we'll link that variable, and we're basically done with that. And so now we have an integer over here that says 0. Let's move this to 180 and see if it affects our servo motor. And it does indeed. It moves the servo to 180. And we can type in 90 here to center it. And it does move the servo. Now I'm going to add another widget over here because I want to show you something. We're going to add another one to control the servo. What would be good? A slider would be great. We're going to link that same variable. So you can link the same variable to more than one widget on a board. I'm going to link that variable. And we're going to make the range go up to 180 over here because that's correct. And we're done. And you'll notice it has the same value as the other one. So if I were to go and, let's say, change this again manually, the servo moves, and you'll notice the other widget, because it's linked to that value, also moved as well. So if I move it up, I can move the servo using the widget. And you'll notice that the two of them track each other. So let's just take a look at what's going on over here. We've got two widgets here, and they're linked to a cloud variable. That cloud variable is controlling the position of our servo. So every time we make a change to it, the widgets both respond to that, or they can affect the change if they're the one doing it. And this is basically the principle of building a dashboard with the Arduino IoT Cloud. Now there's also a mobile layout for your dashboard, so you can move these around so that on the mobile app they're in different positions, etc. And so you can do both a desktop and mobile dashboard, so it's a very versatile system. Now up until this point, we've been doing all of our editing inside the Arduino Cloud Editor, and you can continue to use the Cloud Editor. It has a lot of good features to it, and you can certainly write your sketches with it. However, it doesn't have as many features as the Desktop Editor, and many people may prefer to use the Desktop Editor instead, and you can do that. So I'm in the desktop version 2.3, and I'm going to go over to my sketchbook. And my sketchbook shows me all the things I have on my computer, but if I click over here, I can take a look at what I've got in the Arduino IoT Cloud. Now, the first time you do this, if you're not connected, you're going to get prompted to log into the cloud. You'll click a button, it'll open a web browser page where you log into your Arduino account, and after that you can close the browser, and from that point on you'll always see the cloud here. Now, all of these sketches that you see are still up in the cloud. None of them are actually on my machine. This is the one that we were working with today. If it was on my machine, this icon here would be a full cloud like this one here. And what you need to do is you need to pull it down. So you'll notice when I highlight it, I get this little cloud with a arrow on it. And if I click on that, I can pull the sketch. And you see down here it says it's done pulling the sketch. And now my sketch has a little full cloud to it. It's actually available for me. And if I double click it, I can open it. And there we go. And here's the sketch that I had up in the cloud. And it is now local on my machine. And I can start working with it. And so now I've modified our sketch to include the push button, and the code I've used is very simplistic. It's not the best, and it's not going to give operation that's completely consistent, but it will serve for illustration purpose because today we're learning about the IoT cloud, not how to code push buttons. Now, as you recall, there's a Boolean cloud variable called button state, and when that state is high, that means the button is pushed, and when it's low, the button isn't pushed. At least that's the logic I'm going for here. So what I've done is I've added a integer constant for the actual button called button pin because we've got it connected to pin 5. And then down in the setup, I've defined the button pin as an input with a pull-up because we don't have a pull-up resistor. And then I went to the loop, and this is where the code is kind of flaky. Now, the proper way to deal with a push button, of course, would be to use an interrupt. But that would complicate the code, and again, I'm just trying to illustrate principles of the Arduino IoT Cloud. So what I've done is I've just put this line into the loop, and I've got my button state, that's the cloud variable, and it is going to be the inverse of a digital read of the button pin because I want it to be high when the button is pressed. When I press that button, it's actually going to go low on the pin, so I want the exact opposite logic. And so that should set the state of the button state cloud variable. Now, the reason I'm saying this code is going to be a bit flaky is because in the loop, first of all, we do this. We do the Arduino Cloud update, and we don't know how long that's going to take, so it's entirely possible that we could press the button and miss it because we're busy doing that, or we could release the button and not see it because we're doing that. So bear that in mind when we're testing this out, but again, we're just illustrating a principle. Now, you can compile and load this locally here in your IDE, but you're going to have to do one thing, and if I go into my thing properties, I'll show you what it is. In thing properties, we're calling two libraries, Arduino IoT Cloud and Arduino Connection Handler. Neither of those libraries are installed by default in your IDE. If you go into this and go and install the Arduino IoT Cloud by going to your library manager, you can install that and it'll install a number of dependent libraries, including this connection handler. So you're going to have to do that before you can compile this. But once you've done, this should be able to compile, and you can actually load it directly onto the board from here and give it a try in the cloud. So let's go and do that. And it seems to work. And another thing that we can do, of course, is that since we're out of sync now with what's in the cloud, there's another button here to push everything back up. So I can go and push this back up to the cloud. It's telling me I'm going to overwrite what's in the cloud. I'm going to do that. And it's pushed back up to the cloud. So now my sketch in the cloud is synchronized with this. And it's a good idea to do that because even though I did load this onto the Arduino from here, I don't want the two out of sync, and so I can work on the cloud without worrying that I don't have the same code as I have down here. So let's go and see if this worked. So now that we've added the code to our board, the next logical thing would be to go to our dashboard and add an element to represent the push button. And we can do that in a moment. But where I am right now is in the thing, and I want to look at the cloud variable. So I've magnified my screen quite a bit so you can see it. This is the button state cloud variable, and it says the last value on it is false. Watch what happens when I press the button. You can see it goes to true when I'm pressing it. And that basically is proving out that our code is working. It's going true every time I hold the button down. And this is a great way of testing and troubleshooting to see if your cloud variables are working. It gives you a lot of data over here, the current state of it, the last time it was updated, etc. So if you're having problems with your cloud project, you might want to go into the thing and make sure your variables are operating the way that you think they should. And now we're back in the dashboard. And I want to show you something in the dashboard I didn't point out earlier. You'll notice right now I don't seem to have the option to add any widgets, and that's because I'm in view mode, the mode you would normally keep the dashboard in when you're using it. And you can toggle it over here into edit mode by doing that. And now I can add more widgets and move them around. So I'm going to add a widget to this for the push button. And a good widget is probably the LED widget. And the LED widget is basically just an indicator. You can make a red LED, a green LED, or you can actually have two LEDs as well, a red and a green one. Now, we'll link that, of course, to a cloud variable. And the button state, the Boolean, is the only one it can link to. And we'll say done. Now we'll see if that works. We press it, it's on, and release it, and it goes off. And so the LED does seem to work as well. It's attached to that same cloud variable that we just monitored earlier. And as you can see, it's pretty easy to add things to the Arduino IoT Cloud. So we've examined a lot of cloud features with our Arduino Uno R4 device, and now we're going to add another device onto our IoT network, specifically an ESP32 board. Now I'm just using one of the ESP32 Dev Kits, and you could use just about any ESP32. The key concept over here is we're using a non-Arduino board. We're also going to examine another couple of concepts, one of them OTA, or over-the-air updates. This is a great feature that allows you to update the code on your board without disconnecting it from the cloud and connecting it to your computer. You can just do your updates directly over the cloud. That's a really handy feature. And another thing we're going to work with are device-to-device communications, where our two microcontroller boards will be able to talk to one another using cloud variables over the Arduino IoT Cloud. So let's go and see how we hook up our second microcontroller to our cloud. We're going to expand our IoT Cloud network by bringing in another board, and that board is going to be an ESP32. We'll attach a potentiometer and an LED to our ESP32, and then we'll attach it to the Arduino IoT Cloud. By doing this, you'll learn how to add a non-Arduino device to the cloud. We'll also be able to experiment with the device-to-device direct communications, and we can work with over-the-air updates to update the code on our devices while it's connected to the IoT Cloud. I'm using an ESP32 Dev Kit module for this, and you could pretty well use any ESP32 that you want. If you don't have the GPIO pins that I'm using, you could just change them in code. We're also going to need a potentiometer, and I'm using a 10K linear pot, although any value above 10K would also work. Just make sure it's linear. A light-emitting diode, and I'm just using a standard red LED, and a dropping resistor for that diode, and a 150 ohm resistor will work well. We'll begin by connecting one side of our potentiometer to the 3.3 volt output on the ESP32. The wiper of our pot will be connected to GPIO pin 34. This is also analog to digital converter 1 channel 6. And finally, we'll connect the other side of the pot to one of the ground connections on our ESP32 module. We'll connect GPIO pin 4 to one side of the dropping resistor, and the other side of that dropping resistor will go to the anode, or the long lead, on our LED. The cathode, or short lead, on the LED will be connected to one of the ground pins. And that takes care of our wiring. Now let's add our ESP32 to our Arduino IoT Cloud. Okay, so of course the first thing we need to do with our new board, the ESP32, is to add a new device to the cloud. So I'm in the device setup wizard again, and this will be a third-party device. So we'll go into here and we can select ESP32. Now there's a drop-down to select the model, and there's quite a few models here, and unfortunately this is not alphabetical. However, you can search it. So I have a W Rover one, and this will be the ESP32 Rover kit, all versions. We'll continue, give it a name, and I'll give it a new name, of course. It's probably a good enough name, and again, I'm going to copy it and download the PDF with that name on it. Saved my device. and I'm all set. There's nothing else to it when you're selecting a non-Arduino device. It's actually pretty quick. And so now my ESP32 has been added as a device, and we can start the code for it. So now that I've added my ESP32 in as a device, I've created a thing for it, which I named ESP32 Thingy. Now I've got my associated device, that's the device that we just set up, and I've added my network credentials and my secret key. And I've also added 2 cloud variables for the 2 items we have attached to it. For the LED, I have LED control, and this is a Boolean. It's got read and write permission because we need to be able to write to it to control the LED, and it's updated on change. The other one I added, I called pot_value, and this is an integer. It's read-only because we're just going to read the value of the potentiometer, and it's also updated on change. Threshold of 0 means it's a minimum change. You can set that threshold so it doesn't update all that often if you wish. Okay, now we'll go and look at the sketch in the simple editor, although as you know, the simple editor is going away at the end of March, but it'll show us what we need to know. And so it's already said we've got 2 cloud variables, pot value and LED control. I've added the code already for the pot, but not the LED. So we define the pin for the potentiometer, that's on pin 34, and the only other code to add is in the loop, and this is where we get the value. So pot value is the cloud variable, and it's going to be the value of an analog read of the pot pin. So that's pretty simple. So let's go back into the ESP32 thingy I have over here. We'll take a look at my board. I've got the pot here, and as I'm moving the pot, as you can see, the values are going up and down. All the way at the top, it's 4095, which is what we would expect as it's a 12-bit analog to digital converter in the ESP32. And at the other end of its travel, it's 0. And so we've already set up our cloud variables and our thing for our new ESP32 board. Okay, now we're back in our dashboard, and we're going to add a widget to connect to that potentiometer. So we'll look in our widgets, and there's a number of ones we could use. I decided I want to use a gauge. A gauge is an interesting widget as it can display numbers. Now you'll notice the value range at the bottom. Look at the format of it with the decimal points. Watch what happens when I link it to a variable. So I'm going to link it to a variable on ESP32 thingy, and that's the pot value, the only one that'll work with it. It's an integer. So I linked the variable, and now if you look, the range has gone to integer ranges and not the float range it had before. The top, however, at 100 is insufficient for this pot, so I'll have to change that. And then we can click Done. And now let's move the pot and see if that works. And there you go, all the way up to 4095. All the way down to 0, and all kinds of values in between. And so the gauge works. It was a very simple matter of connecting it to a cloud variable and getting it to go. So I've gone back and modified our sketch to add some code for the LED. Now you remember we have a Boolean called LED control. That's our cloud variable, and we're going to use it to control the LED on and off. So I've added an integer to represent the pin the LED's on. It's on GPIO pin 4. And then down in setup, I've set the LED as an output using a pin mode command. And then I've gone down to the bottom where they gave us a function called onLEDControlChange. And in there, I've added the statement to do a digital write to the LED pin with the value of LED control, the cloud variable. So that's a Boolean, so if it's high, the LED should go on, and if it's low, the LED should go off. Now, all that's pretty simple, but I've done something a little differently right now that I wanted to show you. If you take a look at my ESP32 board, you'll notice it's being powered now by a power bank instead of being connected to my computer. And I'm going to do what's called an over-the-air update. You can see over here it says over-the-air. And so what this is going to do is it's going to update over the cloud. It's going to let me update the code without having to disconnect the microcontroller and connect it to my computer. And of course that can be very, very handy when you've deployed a number of cloud-based microcontrollers. So let's just update it. It's going to go through the verify. We'll open this. We'll see if we can get some information in the console. and it says the upload over the air has succeeded, and we've updated our code without even having the microcontroller attached to the computer. So now I'm back in my dashboard, and we're going to add something for the LED that we just coded for. So let's just go into edit mode, and we'll add a push button. That sounds like a good way to control an LED. Link it to the variable of LED control, the only Boolean that we have here. And that's about it. And so what happens when I press the button? I'm holding it down, the LED is on. I let go, the LED's off. It's pretty well the behavior that we expect. And so once again, you can see how simple it is to add items to the dashboard on the Arduino IoT Cloud. Now the next thing that we're going to look at is device-to-device communications. We now have two devices, the ESP32 device and the Arduino Uno R4. And we've already seen that we can use one dashboard with both devices, but we can also make them communicate directly. And we do that by synchronizing their variables. Now in order to do that, we need cloud variables that are of the same type. So you can only synchronize a Boolean with a Boolean or an integer with an integer, etc. So what I'm going to do is set it up so that pressing the push button on the Uno R4 will light the LED on the ESP32. And I'm in the thing for the Uno R4 right now, and I'm looking at the button state button, and I'm going to edit the properties of that button. And so this is basically the same screen you get when you first create the button, and you can do this initially when you create it if you wish. You'll see this thing that says sync with other things. We'll click on that. And now it's going to show me all of the different Booleans that I have with all the devices in my cloud, because you can only sync between the same type of variable. Now button state is the one we're trying to sync, and I want to sync it with LED control on the ESP32 thingy. So I'm going to click that one off, and note that you can sync multiple variables if you wish, and click synchronize variables. And I'll save that. And so now you'll notice there's a little thing over here that says the variable has been synchronized. So let's go and test that out and see if it works. Okay, so we're going to test out our synchronized variable, and so as you can see, I've got my white push button over here and the LED over here in the ESP32, and press the button and the LED lights. Let go of it and it doesn't. It's pretty simple, and we have synchronized those two variables through the Arduino IoT Cloud. Now, of course, we could do this the other way as well, and I've got a little bit of a homework for you if you choose to go ahead and do it. Your mission, if you choose to accept it, is to take the potentiometer over here and have it drive the servo motor that's over here. Now, both of these devices are using integers for their cloud variables, so you can synchronize them. However, the pot is giving you a value of 0 to 4095, and we need a value of 0 to 180 for the servo. So what you would need to do is you'd need to modify the ESP32 code and add a map function into it to map that down to 0 to 180, and then synchronize the two variables. So give that a shot. You should be able to control your servo motor with the potentiometer on the other device, proving out the cloud-to-cloud variable synchronization in the Arduino IoT Cloud. Triggers are a relatively new feature in the Arduino IoT Cloud, and we haven't discussed them before. Triggers allow you to send off a push notification or an email in response to an event. And you can use triggers for a number of different monitoring applications, or you can use it just to send yourself a regular status report on something. So they're very useful. Now, we have a push button on one of our microcontrollers, and it seems to me that that would be an excellent device to fire off a trigger. So let's go and see how we would set that up. So here's our existing IoT Cloud setup. Let's bring the mobile app in. We can use triggers to send push notifications to the app. This is how this is going to work. One of our devices, which in our case is the Uno R4 Wi-Fi board, has a push button on it. That push button state is maintained by a cloud variable called button state. When the button has not been pressed, the button state will be 0 and nothing is going to happen. However, if we press the button state will change to 1. This will cause a trigger to be fired and will send a push notification out to our mobile app. Let's see how we set this up. Now, in order to create our triggers, we will go into the triggers section of our console and add a new trigger. And first we'll give our trigger a name. So let's rename the trigger to, I don't know, how about button trigger? Okay, now we need to associate our trigger with a cloud variable, and so we're going for one on our Uno test board thing, and the button state variable, which is the Boolean that will change state every time the push button is pressed. Now, if you can see this here, it says if the cloud variable button state from Uno test board thing is true, then you take an action. And the action we're going to take is to send a push notification to the app on my phone. You could also send an email if you wish. So send a push notification. It's telling me who it's going to, which is myself. We'll give it a title, button pressed, and some text. The white button was pressed. Now you can also use variables inside here if you're passing a string instead of a Boolean. So you can use the thing name and the variable name inside there and put it inside your message if you wish. But this is all that we need right now. So I'll say done. Turn my trigger on, and we should be ready to go. Okay, well now it's time to test our triggers, so we will press the push button. And on my app, I've got a notification that says the button is pressed. The white button was pressed. And on the console, if you go under the history, you can see the triggers. I've actually pushed it twice. So here's my button trigger, and it tells me exactly when it is I have pressed this. So you get a record of all the triggers as well, and that's a pretty handy thing too. So as you can see, triggers is a very handy feature in the Arduino IoT Cloud. And so that wraps up our look at the fundamentals of the Arduino IoT Cloud. You should be able to take the information you learned today and start creating some amazing cloud-based applications. Now, if you want some more information about what we covered today, there is, of course, an article on the DroneBotWorkshop.com website that accompanies this video, and there's a link right below the video to that article. Now, I want to let you know what we're going to be covering in our future Arduino IoT Cloud videos. We're not going to do these back to back. I'm going to slip a few other videos in, but since I started to make shorter videos, I should be able to make more and more of them, so you'll be seeing a lot more DroneBot Workshop videos, including some upcoming cloud videos. Now, what we're going to be covering in the next cloud video is MicroPython. Everything we've done so far has been with C++, but you can also use MicroPython with the Arduino IoT Cloud, and so we're going to see how that works. And we're going to do another video on using your Amazon home devices, your ALEXAs. I don't want to say the word because there's one behind me over here, but by connecting your Amazon home devices into the IoT Cloud, you really open up a wealth of possibilities because, of course, these devices can control so many things already. When you add them onto the cloud, you can pretty well control your whole world. So you'll have to take a look out for those episodes. The best way to find out about the episodes, of course, is to subscribe to the YouTube channel. All you need to do is click that red subscribe button, and if you click on the bell notifications, and if you've actually enabled notifications for YouTube, then you will get notified every time I make a new video, including videos in the Arduino IoT Cloud. Now, when you're on the website, you might want to sign up for my newsletter. It's not a sales letter, just my way of keeping in touch with you to let you know what's going on in the workshop, and also to let you know what the subject for future videos is going to be, and it's free to sign up for the newsletter. And another freebie to sign up for is the DroneBot Workshop forums. If you want to discuss your cloud projects or anything related to electronics, the forum is a great place to go. It's free to sign up, and there's information for doing that right below this video as well. And so until we meet again, please take care of yourself. Please stay safe out there. Enjoy using the Arduino IoT Cloud, and I'll see you again soon here in the DroneBot Workshop. Goodbye for now.